Okay, let's continue on with our discussion. So we talked about this whole polymorphism and dynamic binding idea, right? Where we could take a parameter of the object type. This is what a method M is going to do, and we can put any object into X. We can put as we saw in the example I just showed you, we could put person, we could put student, we could put graduate student, because they're all an object. Okay. All right, so we can use any subtype to put it into that type of variable. That's called polymorphism. Okay, a lot of reading, but basically what it means is that if we have a parent class variable type, it can take an object, it can be assigned an object of any child type, of itself or any child type. So if there was a child of the string class, for example, you could put that into a string variable, right? You couldn't necessarily, as we'll see in a moment, put a string object into a subclass variable. All right, that's a slightly different thing, okay? And we can see how we can do that with what's called explicit casting. So here, if we have, some object type here, all this, anything that's a child, like Cn-1 here is a child of object. It's what we call an instance of Cn. Okay. So if we have an object, some variable called O, that's it's C1, we would say C1. Sorry, O is an instance of C1 because it is a C1 object. But it's also an instance of C2 because C1 inherits from C2. And then class 1, class 2, that's what C stands for. Sorry, maybe you should have made that clear. All right, so if we think of this as object, person, student, graduate student, if we had a variable of type graduate student and an object of type graduate student, we would say that, an object, let's go back. If we have an object of type graduate student, we would say that object is an instance of graduate student. It's also an instance of student. It's also an instance of person. It's also an instance of object. Okay, this is important because we're going to get into the instance of keyword. All right. Let's talk a little bit about that. Okay, I think instance of comes up in a couple of slides. Let me go find it. All right, instance of operator. Okay, we'll come back to those slides I just skipped over in just a moment. Okay, so the instance of operator tells whether an object is an instance of a particular class. So here, notice we have a variable that's an object variable. And we put into it a circle object. So the variable is an object. It points to a circle object. Now, when we go to compile this, the only thing that we know is that the variable myObject can hold any object of type object or its children. So we can ask the question, if myObject is an instance of circle, so does the myObject variable point to something that is a circle? And if so, then we run this code, and otherwise we skip over it. Okay, so we can use the instance of operator to tell whether a particular thing, make sure I'm going to go back correctly. Okay, can tell whether a particular variable points to an object of a certain type. Now, this object variable, I could put any object in there. I could then change later on. I could change this to be a string. I could change this to be a rectangle. I could change this to be a student object, right? But the question is, when it gets to this if statement, it's going to check true or false is it an instance of the circle class? Right? And then it will do this thing. We'll go back and look at the couple of slides before this for what's called the explicit casting. Okay, so let's go back real quick. Talk about implicit versus explicit casting. Okay. So here, I can put into the O variable a student. Okay. I can put into the O variable a student object. Why? Because a student object is a type of object. So this has no problem. I can then call the M method that takes an object variable with this, right? This is what's called implicit casting. It's saying this can point to anything of type object. This is a child of the object class. Therefore, there's no problem. We can do that. Okay. There's also this thing called explicit casting. Okay. And we'll talk about why this works, right? The explicit casting, why this is a problem. Okay. So now let's say after I create that object O equals new student. So back up above, I did object O equals new student right here. All right. And then I say, okay, I want to take that object O and I want to put it into a student variable. Now, if I try to do this, I will get a compiler error. And the reason why is because the compiler, the only thing the compiler knows is that this O variable can hold an object. It doesn't know what type of object it holds. It only knows it can hold an object. Is that object a student? It doesn't know. The compiler doesn't know. So when we go to say, I want to put this object into the student variable, the compiler is going to say, I don't know if I can do that. So it's going to give you a compiler error. Okay. Now what we can do is we can cast that O variable to say, I want to take what's in O and I want to make sure it's a student. And then I can assign that to the student variable B. Okay. So this is what's called explicit casting. I think there's an example here, right? Yeah. So when we cast something from a superclass to a subclass, we must use explicit casting. And one thing is this type of casting may not always succeed. If I have what's in O, if it points to something that's not a student, let's say at some point between O equals new student, sometimes later I say O equals new person, and I try to cast it to a student, it will fail. Because a person is not necessarily a student. All right, so that's how we cast from a superclass to a subclass. And so now we're back to the instance of operator. Okay. So maybe to help understand casting, we may consider that a fruit is a superclass because fruit is something that's overarching, right? A much more general explanation of something. And we would say an apple is a fruit, an orange is a fruit, but a fruit, if we have a fruit, we don't know if it's an apple or an orange or a banana or something else. Right? And in the same way, if we have, let's say, a person class, and we have a teacher class, and we have a student class, right? If we have a teacher is a person, hopefully that makes sense to you, right? That you would agree that a teacher is a person. A student is a person, but if we say, I have a person, we don't know if it's a student or a teacher, right? So it works in one way, not necessarily always in the other direction. Okay, so we'll look at some examples of casting. All right. But another thing that I want to help us understand too is this whole equals thing. So remember we talked about this a few times, that when we use the double equals operator, right, then what we're really saying when it comes to objects is, do they point to the same thing? Do they have the same memory address? Right? Which isn't always really what we're interested in. Sometimes we want to know, do two things have equivalent information? Not necessarily are they the exact same thing. For example, let's say that my son gets a new Iron Man t-shirt. Right? He goes to the store, he buys a new Iron Man t-shirt. He really likes Iron Man. And he goes to go play on the playground with his friends. And his friend says, "Hey, I have that t-shirt." Now, does the friend mean, "Hey, that's my t-shirt, and you stole it and you need to give it back to me"? Or is he meaning, "I have the same t-shirt. It's a different physical t-shirt. I have the same logo, I have the same color, it looks just like mine at home. I maybe probably bought it from the same store that you did," right? That's what he means, right? When he says, "I have that t-shirt," or "That's my t-shirt," or "That's just like my t-shirt." Like, what he means is that they're the same, even though they are not the exact same t-shirt, right? Or if I buy a new car or a new computer and someone says, "Oh, hey, I have that car." No, you don't. That's my car. I bought it. No, what they mean is, they mean I have the same car, the same make, the same model, maybe even the same color, but probably not usually. It doesn't have to be that way, right? So here, what we say is, like, if we wanted to say, do two circles contain the same information? Well, we could say we could redefine the equals method inside of a class, all right, as two different circles have the same radius, and then they're equal. Well, according to our definition based on the geometric object class that we talked about, the two different circles could have different colors, could have different date created, but as long as they have the same radius, we'll say, yeah, they're equal. Right? A really useful implementation of this, the really useful tool for an equals method, and we'll talk about this in the coming weeks, is for the purposes of sorting things. So we like to sort things in an array or an array list. Right? Well, if we're going to sort two things, we need to have some way to compare them. Right? We need to know, are they equal? Is one less? Is one greater? Well, for a circle, we might say, the radius. Yeah, let's just go with the radius. Whoever has the smaller radius is a smaller circle. Whoever has a larger radius, doesn't matter. Color, date created, that's not what's important. And we might define it that way. All right. In the same way, if I was sorting a list of students, if I had a bunch of students with student IDs and names and all that, right? I might want to sort you guys by student number. All right. So two students would be considered equal if they had the same student number. Might want to sort you by first name. All right. Two students would be considered equal if they had the same first name. Okay. So this is how we can do this. And the way that the equals method it exists in the object class, so we have to override it, right, is that it takes an object parameter type and it basically returns that they point to the same thing, that they have the same, that they use a double equals. We'll override that by saying, okay, if what I get past O, if it's an instance of circle, then I check, does the radius of my current circle, remember this is the local variable, this is the class variable, does the local radius equal the circle that I'm past, its radius? And if so, then they are the same. They are equal. All right. If they are different, then this will get returned false, because if radius does not equal radius, then radius of what my object has does not equal the radius of the thing that's passed, then I'll return false. And notice this else here also returns false, because if the thing being passed is not a circle in the first place, then they can't be equal. Okay. So we can override the equals method. There's a compare to method and a compare method for the purposes of sorting things. We'll talk about those. Okay. Again, the double equals used for comparing two primitive types, right? Or if they have the same reference, do they point to the same thing? Equals is what we use to try to determine, okay, they don't point to the same thing, they're not the exact same object, but do they basically have the same thing in them? Do they have something that's equivalent? Okay. One useful tool is the array list. So arrays were cool. Arrays were nice for us to be able to have a grouping of similar things, all ints or all doubles or whatever, right? But one of the big problems with arrays was, one, it was fixed, right? It was a fixed size. If I made a size 10 array, that's all it could be. It can only ever hold 10 objects, or 10 integers, or 10 doubles, or whatever, right? And if at any time I had an array of size 10, but I needed a smaller array, I couldn't really. I'd still have just extra space just kind of hanging out there, right? So the array list is a class that we can use to be able to treat things like an array a little bit, but it's dynamic, which means that if we can just keep adding new things to our array list, and it won't have a problem. If we create an array list that initially holds 12, I think 12 is the initial number of what it makes, but if we make an array list of size that initially holds 12 things in it, and we want to add a new object, we want to put something else on our array list, that's fine. It'll just increase the size of the array list. Right. There's some other fun methods here. So if we want to add something, we put it in there. We can add it at a particular place and shift everything else, right? All right, or is that insert? Yeah, no, it's add, and we put it in there. Okay. The set is what replaces what's already there. So add always puts a new element into our array list. If we add it at a particular index, then it shifts everything else. Contains is cool, right? It's a nice method that tells us whether or not a certain object is in our array list. Okay. We didn't really have that with arrays, did we? Now, get is the way that we access an array at a particular index. So this would be like the brackets. When we use the bracket 0, for example, we would get the thing at index 0 at the first index. Here we use the get method to access what's at that index. But we can also find out where a particular object is if we pass it, say, okay, index of object, I want to know where this thing is. Right? Using index of with contains could be really useful, all right? Because this would give us an error if the thing didn't exist in our array list. We can remove an object from our array list, again, shifting everything around. All right. We can remove something at a particular index. And we can set a value. So this would be like if I were to take that bracket of whatever and equals, array bracket 0 equals whatever. This would be like the set here. It replaces what is in that at that index. Okay. I think array list. Yeah. So this is a comparison of how we would do things with an array versus some things that we would do with an array list. So notice that array lists are more powerful. There's more we can do with them. Right. But they are also a class, which means they're an object. They take up more space. There's some other stuff, but they're more powerful, so they're more use. They can be more useful. All right. I want to go back a slide because one thing that we'll do when we create these array lists is within this greater than, less than, greater than symbols, is we'll say, what will our array list contain? So here, if I create an array list of type string called cities, it means that I can only put strings into here. Okay. If I made it object, array list object something, then I could put any type of objects. I could put integers, I could put double, like the class type. I could put strings, I could put person, I could put grad student, I can put apple, I can put fruit, everything. Okay, if I make this object. Okay. So an array list can be used to store kind of a mixture of different types of things. Okay. All right. I'll leave this one for you to look at. All this code, again, all these examples are available on the class materials folder. One thing that was asked earlier today was about this protected modifier. I generally don't use the protected modifier myself. I'm not really sure why. I guess there are probably some situations where it'd probably be used. That's why they have it. Right? But basically, the main modifiers I would use are private and public. Those are the ones as far as for this course is concerned. Now, maybe once you start writing, if you ever write Java code for a company, for a client, once you graduate, or even once you have an internship or something like that, you may find yourself in need of some of these other visibility modifiers. But I would say for this class, I'm not going to give you an assignment that would really require you to use anything outside of private and public. That can't be done without using just private and public. Okay. Now, but it's at least a good thing to know kind of how the visibility and accessibility works. So public just basically means anyone anywhere can access it. Private means only the class itself can access it. Okay. The default, if we don't put any visibility modifier at all, means our class and anybody from the same package can access it. Part of why I'm not really giving you anything that's going to use some of these additional visibility modifiers is because nothing in our class this semester is going to involve creating packages. That's kind of more of an advanced thing and not really necessary in this 102 course. All right. But someone did ask about the protected modifier, and the protected modifier on a variable or method means that the class, anybody in the same package, and even anybody in the subclass, even if it's not in the same package, can access it, can access the variable directly. I am more of a as far as the way that I do a lot of programming, I like private access, because generally what we do is we create a variable that's private. We create a variable that's private, and then we create public get and set methods to control what those values can be. Even the protected modifier, if I have a variable, if I have a subclass, a child class, hold on a second. If I what I was saying was, if I have a child class that can access a variable in my parent class, then it can change its value to an invalid value, and I won't notice. So, say for example, let's say I have the person class with the name, what was an example? Let's see. Let's say the trying to remember what was an example of a variable that. Okay, so like in the assignment, for example, the person class has a restriction on email of what format it has to be in. Oh, by the way, there was a question about that I meant to answer as well. It just needs to have a string of characters, the @ symbol, a string of characters, a dot, and then a string of characters. Right. So the domain could be like our domain, which is .edu.tr. Right. So the domain can have a dot in it. That'd be fine. It just has to have that format. That's really all you're checking. Okay. So let's say the email must be of a certain format. And let's say I made the email attribute protected. Then someone could come along and create a child class of person that could change the email not using the get method, not using the set email method, and they could change it to some value that's not valid, right? And that would be a problem, right? Because then they would have control over a variable that I don't really want them to have ultimate control over. Okay, so that's generally why I don't use the protected, because it's either going to be a method that I'm going to probably do a public on and make it accessible to anybody, or it's going to be a variable that I'm going to make it private, and I control with my code, with my get and set method, I control what they can and cannot make that variable's value. Okay. All right. So the discussion of that. So this is just a good thing to know of how these different visibility modifiers can impact our ability to access these things. Okay. All right. A subclass cannot weaken. So basically, a subclass would not be able to take a protected variable or a protected method and make it public. Okay. All right. Right. Yeah, so it cannot take a protected method to make it public. And oh wait, actually I guess it can. I'm the other way around. We could override a protected method and change it to public. See, that would also be a problem in my opinion. That could result in a lot of problems, but cannot weaken the accessibility. All right, so it cannot take a public method and change it to private. Right. Okay. Oh, final is a keyword. We talked about final. Final variable is a constant. We talked about that last semester. Basically, it cannot be changed. So we cannot take a final method and override it. We cannot take a final class and make it extended. So a final class cannot be a parent of a child class. Anything defined as final in a class, any variable or method defined as final in a class, if there are children of that class, subclasses of that class, they cannot change the value or the method. Okay. All right. What time is it? All right. Well, so let's look at a couple of examples, and what we may just do is, because that's the topic for today, what we may just do is go ahead and after I look at a few examples with you guys, then we can end for today. Quite a bit early, actually. Okay. Share. There we go. Okay. So one thing I wanted to do was I had wanted to talk about this whole instance of operator. Okay. So here's an example of our implicit casting. So remember, we can take any object of any type and put it into an object variable, and no problem. Okay. So, all right. Let me move this one up, and let me also change this object. Okay. All right. So I could take this object O and I could put it, I can make it a graduate student, and it compiles and runs just fine. In fact, let me do one other thing. Let me comment out these so that the only thing we see is what's displayed off of this one object O for now. All right. So object O is a graduate student. I can put in a student. Yeah, so it prints student, and the reason why is because grad student just uses the toString method of the student class. Okay. I could put in a student. Oh, look, there it is, student. I can put in a person. Oh, person, good. I can put in an object. Object. Oh, wait. On check. Yeah, okay. A little too fast on the typing. Okay. And what happens is I get this thing. Okay. So let's go back to graduate student. I can put it into a student variable. All right. And that's fine. That's a student. Perfect. All right. I could put a student into a student variable. That makes sense. This is what we do probably more often than anything else, is put class type for the variable and class type for the constructor as the same thing. All right. What I cannot do is I cannot create a person object and put it into a student variable. This is going to give me an error. All right. Person cannot be converted to student. So we cannot take a person object and put it into a student variable. All right. Back. Student. Okay. And object. Now, let's take a look at this instance of operator. Okay. If O is an instance of graduate student, okay, then I want to take the graduate student and explicitly put it into a graduate student variable. And this should be okay, right? And the reason why is because this O variable was assigned a graduate student object. And I just realized how I wanted to do this. I wanted to show this using the whiteboard stuff. So I'm going to pull up the whiteboard so that we can take a look at that in just a moment. Okay, so I can push it into here. And then I could say MGS here. All right. Now I could say, okay, well, what if is O an instance of student? Now I'll compile this. Okay. Notice no compiler errors. Okay. It runs just fine. And the reason why is because this is true because a graduate student is a type of student. So O points to a graduate student. All right. O points to a graduate student. Graduate student is a type of student, so I can convert that. Now, what about this? What I'm going to do now is I'm going to take O and I'm going to put a student object in it. Is this true? Is O an instance of student? What do you think? Is O an instance of student? Yeah. Oh, I just noticed that some of you guys had some questions. Sorry, I forgot. I didn't notice that before. Recep Samet. Do object A equals new circle. A can use directly any methods that are in the object class, but we would have to use explicit casting to use methods that are in the circle class. Right, Arjun. For these assignments, the only thing I expect you to be able to do to access variables to change and get their values is to use the get and set methods. All right, that's what we talked. Yeah. Okay. Let's see. So this compiles. Does this compile? Does this compile? Yeah. Okay. That works. But I get an error. Oh, I get a runtime error. And the reason I get a runtime error is because O points to a student object. Therefore, O is an instance of student, but it's not necessarily an instance of graduate student. Okay, so that's why I get a runtime error. The casting, right, class student, which is what the O is, cannot be cast to class graduate student. Right? So get a runtime error for that. Okay. Let's see what else. Is my whiteboard up yet? Yes, it is. Good. All right. Let's. Oh. So I'm kind of show you what I mean by these things. Okay. So let's hope this works. If I were standing at a whiteboard, it'd be a much better situation, I think. Because I could write code and stuff. Okay, so here we talked about this parent stuff. Let me erase some of this. Okay, so when we create a variable, let's say we're creating a variable of type person. Okay. Let's call it P. All right. But then we can take an object out here. It could be a person object. All right. We can have an object out here that's a student object. We can have an object out here that's a graduate student object. Student. This writing words is terrible. Okay. And what I'm going to show you is over here we created these objects. Now, remember from the way that we did find this is person is the parent class, student is a child of person, graduate student is a child of student. And what we're going to do is we're going to create 3 variables over here. We'll create a student variable. Call it S. We'll create a grad student variable. I'll do it that way, and we'll just call it GS. Thought my handwriting on its own was bad. Okay. So if I have a person variable, I can point it to a person object. No problem. Okay. I can point it to a student object. I could also point it to a grad student object. All right. All right. Okay. But in order to access the methods of a student, if the variable is a person and the object is a student, in order to access the variables and methods, rather, the methods that are specific to a student, I will have to explicitly cast that variable to be a student. Okay. I can put P equals student. All right. I could put P equals student. All right. But in order to access the methods that are specific to the student class, I will need to explicitly cast it. All right. 1 second. Yeah. Okay. Now, let's talk about these others. I can definitely put a student into a student variable. I could definitely put a grad student into a student variable. What about a person object into a student variable? I mean, isn't a student a person? Can't I have a person object? In a student variable? Wouldn't that make sense? Well, let's take a look. Let's take a look at what happens if we try to do just that. Okay. So let's try to take a student variable and put a person object into it. Let me put that there so I don't get a compiler error there. Okay. And I get a compiler error saying a person cannot be converted to a student. So I cannot take a person object and put it into a student variable. So you may think, well, wait, but a student is a person, so why can't I do that? All right, this is part of the ways that this object-oriented programming works. A person object only has access to person things, person methods, person variables, stuff like that, person definition. So I cannot take it and put it into a student variable. I could do it the other way though. So here we saw this before. I took a person S, let's call it S, and put a student into it. That will give me no problem. And also, by the way, we lost our runtime error here. I no longer have a runtime error. And the reason why is because now O is not an instance of graduate student anymore. By the way, this section of code here can be pretty useful. That if we need to take an object that could be one of a multitude different types, it could be a person, it could be a student, it could, whatever, right? Then we can say, we can check to see, is it an instance of a certain thing before we try to access methods associated with it. Okay. Let me go back to the whiteboard for a second. Talk through one more thing on this. Okay, so we cannot put that. I'm going to draw it in red to say we cannot do this. We cannot take a student variable and point it at a person object. Okay. We of course can take a graduate student and put a graduate student object in it. No problem. But we cannot put a student, we cannot put a person object into a graduate student variable. So think about it this way. The variable can contain the same level or any children. So the person can contain a person, it can contain any child of the person class. But a variable of a certain type cannot contain an object of a parent type or of a superclass type. All right. Let me take just a few more minutes of your time so I can do one more example and pull up one more example of one thing we talked about today. Which one was it I wanted to do? Not the casting demo. Oh, I did want to go ahead and talk about the array list. Okay. All right. Well, oh, because I don't have this in the. This is, what's the simple geometry right here? Oh, because the chapter, I know what it is. Maybe this is it. There we go. Okay. All right. So we're going to have a couple of different array list things here. Right. So we're going to have an array list of strings, and we're going to put, cities into there. And what I'm going to do is I'm going to use this fun canvas thing, and I'm going to take my array list, and I'm going to put it in here. Okay. Now notice it doesn't have anything in it yet. I haven't put anything in it yet. But now when I add one value, okay, notice it looks very familiar, doesn't it? It looks a lot like the array used to look, right? So now I'm going to add a few more values, right? And notice it's just keeps adding them to the end, okay? So now if I wanted to say, okay, what's the list size? How big is it? Well, the answer is right here because the canvas gives us that, right? But it's however many objects are in our array list right now. So it would be like the, in a sense, it's like the array dot length, right? But notice that this array list here, let me show you this. I can have up to 10 values in here as it currently is, right? So my array list size isn't going to be 10, because even though I have 10 available locations, the size is telling me how many values are in here, how many objects are in here. All right. Okay, and we can check and see, is Miami in the list by saying, does it contain Miami? Miami in the list, true. Right. We can tell me what the index of a certain thing is. The location of Denver in the list, index 1, right there. Yep. Okay. And is the list empty? No, it has stuff in it. Now notice I can add at a particular index. So I want to add Xi'an. Unfortunately, I don't know Chinese, so I think you would pronounce that Xi'an. And so I can add that at index 2. Notice it puts at index 2 Xi'an, and it moves everything else. It doesn't overwrite what was there. It moves everything else over. Okay. I can remove Miami from the list and move everything else over. I can remove the thing at index 1, which would be Denver. All right. So now Denver's gone. Everything else moved over. Okay. Now, what about the toString method? Now, remember, all objects, all classes have a toString method. ArrayList is a class. It has a toString method. This is what we get when we do the toString method for that. And I can go through city size by printing out each value at a particular index, which basically looks the same as what you guys have done before. Actually, it goes from, I'm sorry, it goes from the end of the array list to the beginning. And I think, you know what, you're not seeing, you guys are not seeing what I'm looking at, are you? You're not seeing the, what I want you to see. Let me share instead of that particular screen. Let me share my screen. Okay. So this here, this is what I've been wanting you to see with looking like an array. All right. So I can go value by value, printing out from 1 to n. Okay. We could also take an array list and put a list of circles. Right. So I'm going to add a circle with radius 2. So if I take this and move it, look at it in here. So here's my circle here, a circle of radius 3. And I could say the area of the circle, of the very first circle, and get my first one. So I should get whatever 2 times pi is, right? Which is that 4 times pi? That sounds about right. I do want to show one more thing before we conclude for today on this array list thing. What if I added a bunch of new cities? Let's see. Before I remove Miami, I want to add, actually I just want to add to the end. I want to add a bunch of Turkish cities. So I'm going to add Antalya, place I used to live, Ankara, place I hope to never live. No, I'm kidding. It's just so big. I don't like big cities. I don't like really big cities. Well, one of my favorites. I've never been there, but my son's a big superhero fan, so I always joke with him and say, hey, we should go visit Batman sometime so that we can say we went there. All right. So let's see what's going to happen here. Because we're going to run out of space here, aren't we? Remember, we added Antalya, Ankara, Istanbul. What's going to happen? We don't have any more space. We're about to run out of space. Can we add Batman? We want Batman. We want Batman. What are you saying? Somebody commented. Yeah, watch what's going to happen. Not only does it make space for Batman, it also expands it even further. It adds 5 more locations automatically. So an array list is similar. It's kind of like you could say it's a dynamic array in that it continues to move over and over, continues to move stuff out as we fill it up. One problem though is even as we delete things out of here, we remove things out of here, it doesn't shorten it up. It doesn't remove those spaces, so it does kind of keep all that space out there. Okay. All right. So that's how an array list works. All right. I hope that's clear. We'll talk about some other data structures in future weeks, but not today. So that concludes our discussion on inheritance and polymorphism. All right, we'll move on into exception handling. I think that's next week. So let me see. What did I just posted the slides for next week. What was it? Yeah, we'll talk about exception handling next week. All right. So go ahead and get to work. Get finished up on your assignment to do this next week. And again, make sure you get questions to us sooner rather than later. All right, if you have questions, if you're not understanding some things. Okay. All right. Other than that, if there are no questions about today's topic, then I will go ahead and conclude there, and we'll just end there for today. We'll end quite a bit early today because we kind of finished up early. All right. like you could create your own method. It's really much more simple than, like, the way that I did it was much more simple than trying to throw an exception. So we haven't really covered exceptions in this class. It should just be a matter of making a runtime error happen. But you can do any type of runtime error. But if you want to throw an exception, you can throw an exception. If you want to just write a simple one line of code that creates an error condition, that's fine too. Remember, it's a runtime error, not a compiler error. And yeah, so whatever works for you. Just make sure, again, I cannot stress this enough. Taha Hoja wanted me to make sure to say this to you guys. Do not use system.exit. System.exit will likely result in you getting a 0-point grade on the assignment, and I don't want that for any of you. So make sure no system.exit. Okay. Oh, does it leave Google Classroom in there from last year? Sorry, it should be MS Teams. You need to submit it through MS Teams. I'm sorry, Emre. I thought I changed it. I guess I did not. It does say Google Classroom. All right, it should have said MS Teams. I thought I had changed that. All right. Okay. All right. Well, thank you guys again for attending and listening, and I will see you in 1 week. Have a good afternoon. Have a good weekend.